So we welded the mounts. We're able to lower the engine a little bit more.
Right, so yeah, normally you have the mounts, they were here, right?
Yeah, they run there and they sandwich between the water pump.
And come all the way over. So now with the new block, that would get in the way.
Well, you could make it work, but it would be just bullshit.
Right. Yeah. So you got like a kit that comes in here that converts it over. You have to weld those. You have to weld those in down there.
Yeah, you weld the brackets. They fit nice though. We took a plastic dummy block and put it in.
Right.
With the transmission and everything. That's how we located our brackets. Spot welded and pulled it and welded it up tight, and then put the engine in afterwards.
This looks really good.
383 stroked. Small block, 435 horse.
So we're gonna have to get creative on this one.
Oh yeah. Very creative.
Let's see what we come up with. So here's the early T10 transmission that was pulled from that car, and you can see the early mount right over here. And notice that these are 16 spline in the back. These 16 spline output shafts used to twist a lot, so now it's upgraded to a more conventional 27 spline because these yokes were also hard to get. Although they're reproduced now, it's going to be a stronger unit overall. Looking on the front of this unit, we can see that somebody's been in it before. You can see that it's a little bit chewed up over here. Somebody was grinding on it. Doesn't look too good. So this is going to be changed to 26 spline now instead of the conventional 10 spline. The countershaft on the early T10 is also 7/8 inch diameter countershaft, and the Super T10 front section that we're going to be using has a 1-inch countershaft. I know it's hard to see, but the speedometer cable comes out over here on the driver's side. You can see the way it's in the floor and comes all the way up over here and attaches. It's very hard to see, but it attaches right here to the floor and runs around. So everything is going to just fit in the way it should and come out the hole. The whole of the car looks like it was actually cut open a bit. Sometimes people do this for whatever reason, but it should come out straight. Everything should work out just the way it was intended to be. Now, the reason why we like using the old extension housing is because of the cross member having this cross brace like this. Some of the bigger extension housings will not fit that easily up into the floor of the car. New engine, new flywheel, everything ready to go. Pilot bushings installed, ready to go. So today I want to do a short video on the T10 4-speed transmission. The T10 4-speed was manufactured by Borg-Warner Corporation. It was originally, for the first time, offered in 1957 in the Corvette. And the reason why they put it in the Corvette is because they wanted to kind of have America's two-seater sports car actually have a 4-speed and compete with some of the European cars that already had 4 speeds, like the XK120s, the 140s and the 150s, and the XKEs later on. So the idea of the T10 was originally just to create a 4-speed transmission. A lot of people don't realize that the T10 was actually designed by a General Motors engineer who designed the Muncie 4-speed. The patent for the Muncie 4-speed is actually that of the T10 transmission. It's just a little trivia note there. Anyway, so the T10 4-speed was pretty weak because you have to remember that the power levels of those cars in the 1957, 62 era really weren't that big. But then we started getting into big blocks in the mid-60s, and that early T10, they started putting bigger and bigger gears in it. And then pretty much by 63, GM decided to drop the T10 and go to the Muncie. But Ford and AMC and Chrysler kept the T10. And later on, Chrysler came out with their own AA33 transmission when their power levels exceeded the usage of the early T10. But Ford and AMC kept what was called the first design Super T10. Ford had kind of a relationship where sometimes they made their own top loader 4-speed, but a lot of cars also came with first design Super T10s. Now, all these T10 transmissions kind of had little problems, and it wasn't until the second design Super T10 came out, which was primarily offered for GM applications, that it was actually new and improved. It had better gear setups in it, it had different types of bearing arrangements in it. Overall, it was just a better transmission. But what I'm doing today is I'm doing a transmission for a 1961 Corvette, and the extension housings are very unique to those transmissions. These extension housings have a little kind of double mount location on them, and it's very unique to these types of cars because of the cross member, the X kind of cross member in them. And a lot of times people put Muncies in these cars, and they put second design Super T10s in their cars, and they have a hard time fitting the transmissions in the cars and then getting shifters to work out. So Brian Higgins at S&K Speed, they called me up and told me about this neat conversion he did where he designs a new sleeve to retrofit first design Super T10s, which are good for Fords and AMCs, and also a completely new main shaft now that you can use to put in an early T10 transmission to upgrade it to late model Super T10 gears. So now we have the ability to have, let's say, a 288 first gear ratio in a 1961 form factor. It's pretty neat. Let me show you some of these upgrades. So the first T10, Super T10 modification I want to show you is the difference between the first design Super T10 main shaft, which is this one over here, and the second design Super T10 main shaft over here. So the problem with this first design Super T10 main shaft is that you have this small area for first gear to ride on. There's a very little thin lip here. I don't know if you can see this lip. It's very thin. And the first gear we go on here, there's a snap ring groove for the 1-2 synchronizer assembly to be held in place. First gear goes against the synchronizer assembly. And what happens is this bearing goes right up against this lip here. Now the early bearings, and this is also mentioned in my bearing tutorial, have no chamfer on the inner ring of the bearing. So the inner ring can go square against this shoulder. The problem is the bearings for the first design Super T10s are no longer available. So the bearings you get have chamfers in them. And the problem is that this chamfer goes over this lip. And it ends up locking up first gear and burning it up. So the fix is either to find new old stock bearings or upgrade it to a second design piece. So the first gear normally on the first design Super T10 would simply thrust against the bearing like this. And again, if the bearing had a chamfer in it, the bearing would lock up against the surface area. So the second design used a sleeve that went in place with a thrust washer, and then the bearing went against the thrust washer. This eliminated that seizure problem that they had. So Brian from S&K Speed in New York, he developed this main shaft mod called SKM1. What it is, it's a recessed machining in the sleeve that goes on the main shaft and basically covers that area and allows you then to put that flat washer against it. So I'm going to be assembling this transmission with this setup on it with the second design revamp on a first design main shaft. Also, this is a particularly special main shaft because this main shaft is designed to use an early T10 extension housing and an early T10 reverse gear. The early T10 reverse gears had a 6-spline reverse gear. The later Super T10s used a 32-spline reverse gear. This is an early T10 extension housing. It's from a 1960 T10 out of a Corvette. And so what happens is these early extension housings have two different pad locations for the mounts. And the Corvettes had a really tight cross member that came across, and they used a small mount, a lot of them, on the 61s and the 1960s. They use this little small mount area. A lot of people, once these transmissions go bad, they tend to simply replace them with Muncies, and they have adapter pieces that go on the mounts to convert this mount location to this mount location. Here you can see a Super T10 extension housing. You can see the difference in the mounting locations. So the trick is here is that we want to utilize this 1960 extension housing for several reasons, so we can get the shifter to come out in the right location, and it's a lot easier to install in the car. What we're going to do is use that special main shaft with this extension housing with a late model case, and we're going to basically convert a late model Super T10 to use in an early model configuration in a 1960 car. It's never really been done before this way. What we're also going to do is eliminate this midplate that's die cast, and we're going to use a heavy duty midplate. And the cool thing about these heavy duty midplates is they have a stop for the rear bearing in the back here. So it has more support for the rear bearing rather than the rear bearing just being held in with a simple snap ring. These snap rings are kind of thin and flimsy on these plates, and they have a tendency to distort and bend on the high load. So what we're going to do is now use this heavy duty plate. It's made by Rolltech. It's a really cool design. It allows you to put the bearing and seat it solid against the back and use a retaining ring. And that adds a lot to the strength of the unit because the bearing will not try to pound itself through the snap ring because it has an extra ledge to rest against. It's a nice little clean piece. Looks really trick. So why did we want to convert to a Super T10 gear set? The early T10 gear sets had a problem where the engagement teeth wore out quite a bit. They were very soft actually. This is a 9310 nickel gear actually. It's got this little identification mark. A lot of people don't realize that. The 9310 nickel alloy gear sets for the early T10s and some of the first design Super T10s and second design Super T10s had a little drill mark that determined what kind of alloy was used. So normally they use an 8620 alloy, but the 9310 alloys had little drill marks. Problem with 9310 is it tends to wear out a little bit faster. You get these little engagement teeth get all chewed up. But what I want to show you here is look at the size of this gear, and then later on look at the Muncie gear. And you can see that the teeth on the Muncie gear are a little bit bigger. It's a little bit stouter piece, right? A little bit wider. Okay, so the Muncie was basically an evolution of the early T10. Now we want to go look at the Super T10 third gear, and I want you to see how massive these teeth are compared to the Muncie teeth. These are better oiling facilities. They put 4 different oil slots in the gear for better lubrication on the thrust surface, and you can see the size of the teeth. Even though it's a different ratio, you could see the difference on all Super T10 gears had different pressure angles compared to the Muncie's. All right, so I got this whole conversion main shaft all together with the 288 first gear Super T10 gear set on it. Notice it's a Super T10 gear set with that special mid plate, the heavy duty mid plate, but it's got the early style reverse gear and the 27 spline output instead of the old 16 spline output. And it's going to fit in this early 1960 extension housing over here. Now, one other thing I want to show you is on the shifter shafts. This is the later model Super T10 shifter shaft. It's got a 3/8 16 thread over here. And if you notice, the area where the O-ring goes is a little bit bigger in diameter than the early pieces that had the 5/16 thread on it. These had a tendency to snap right over here. So we're going to convert these shifter shafts to later style shifter shafts. This is a little chewed up anyway, but the better shafts makes it more stronger to endure more power shifts. Now, even though reverse isn't really crucial, these end up stripping out and breaking off eventually, so we're going to swap all this stuff out again to the latest style Super T10 shifter shafts and sectors. And these are also TIG welded in place so they don't break, where these are kind of just fuse welded, and they had a tendency sometimes to break right over here. Okay, I'm almost done putting that transmission together, and I just want to tell you one thing. I ran into a little bit of a snag with this racing midplate. Apparently it's designed for a different main shaft, so when I put the stock main shaft in it, the spacing wasn't correct. Had to pull the whole main shaft apart and swap out the mid plates to the stock plate. A little bit of a glitch in the build, but it happens and I might as well share it with you. So I won't be using this mid plate, but maybe on some other jobs I will. I think I'm going to actually make a plate similar to this. It should be out in another couple of months. That's going to be billet, but it's going to kind of have the stock locations and the stock look to it, but it'll be out of billet aluminum. So that's coming. So let me show you what I did so far with this transmission. So the whole purpose of this mod is to do 2 things. Offer better gear ratios for the early T10 in the Corvettes. Utilize the stock extension housing with the stock locations for the old frames on the C1 Corvettes. Stock speedometer location, speedometer gear comes out where it was, but we have the heavy duty case on it now with the steel front billet bearing retainer. It's pretty cool. This is a sealed system now. It doesn't have an oil slinger, so it's got a front seal in here, and now the case is vented. We could use this particular case section from the 60 if we wanted, and then just machine the inside and fit the Super T10 gears in the case. But this is pretty trick. Got a heavy duty case. It's going to be having some new horsepower anyway. It doesn't need to be original, so it's all good. So this is what we got so far. Got this cover I'm going to put on. Got it all done with the seals and everything ready to go. Some new shift forks, some new high performance forks we're going to put in it. Let's button this transmission up. One thing I use is these double lip sidearm seals. They're pretty trick, and they have a little bit of an extra boot on them to prevent leakage. These T10 side covers seem to be a little sloppy in the shifter shafts. Even the new ones and the older ones, they never were as precise as the Muncie's. I torque these side cover bolts down to 18 foot-pounds. And what I'll do is I start from the middle and I work out. I watch the digital readings on the wrench and I'll bring them up to 8. and then go around, maybe do 12 and then 18. Once you start getting past 12 foot-pounds, it starts to set up pretty fast. So you can see here that these mount, it takes the mount way in the back compared to the normal mount over here. And that's why we use this tail. And also the clearances are extremely tight in the frame. Look at that yoke the way it is up there. It's gonna drop in a little bit more, but you can see how tight they are. And that's why you're using the 32 spline extensions. This yoke is dropped down right now because the rear is way down, but you can see how tight the clearances are in the floors. So what do you got for me today?
Got a bunch. Only one COD that I can see.
I've been waiting for this. Take care.
Hey, have a great weekend.
Here it is. Oh boy, am I excited. Before I even got a chance to finish editing the video, I got those Billet T10 mid plates and covers in. Let's go check them out. See what we got here. This is obviously the mid plate cover. Oh, this looks like this is going to be the cover. Yep. Nice, huh? One piece. Like the way they did this lip around for the gasket. That's pretty nice. Feels a little bit lighter than the factory iron cover. We'll see how this works out in the unit. Looks pretty beefy though. I don't think it's going to crack or anything. There's your billet aluminum T10 mid plate. This will work on the Super T10 and early T10s that have the bolt holes right over here for the mid plate to tail tapped in. The ones that don't have these threaded bolt holes, it won't work obviously, but this will work for most of your first design and second design Super T10 transmissions. Let's go take some measurements on this. I'm really curious to see if this thing is accurate. It's a nice solid billet piece. Look at the machining on this. Isn't it gorgeous? I love the way these contours are done. Beautiful piece. All right, the spec here is 498 to 502 on the thickness. Obviously flatness, you want to keep it around 0.002 and less if you can. Let's go measure this, see what we got. I always get excited. Okay, we got 501, 501, 501, 501, 501. Now that's flat. I really like the way this plate came out. It actually exceeded my expectations because the blueprint tolerances were a lot more sloppier than this plate came out, which is amazing. I mean, it's really sharp looking and the machine quality is top notch. And so, that being said, I probably will have this for sale shortly on my website. I don't really know what the cost is going to be right now, but I'm sure that by the time this video is edited and uploaded on YouTube, I probably will have a cost and it will be available to buy. Also, I want to thank you very much for watching this video. I hope you learned something from it. And please subscribe to my YouTube channel if you haven't already. There's also a notification bell on the YouTube page. And if you activate that bell, you'll get email notifications when I upload a new video. So thanks again. I appreciate it. See you soon.